Hey math enthusiasts! Welcome back to Maths with Sass, where we tackle fun and challenging puzzles. Today, we're solving a fascinating geometry problem. Can you find the missing area in this puzzle? Let's dive in. Before we dive into solving, let's quickly recall the formula for the area of a triangle. Area equals half of base times height. The base is any one side of the triangle. The height is the perpendicular distance from the base to the opposite vertex. This formula is key to solving the problem, so keep it in mind as we move forward. Easy, right? If this isn't clear, feel free to check out my triangle area calculation video for a more detailed explanation. Once you got that, let's move on to dividing the triangle. Let's say we draw a parallel line to the base of the triangle. The distance between this parallel line and the base represents the height of the triangle. Now, suppose we change the upper point of this triangle and move it along the parallel line. Notice that we created a new triangle. The new triangle still has the same base length, and its height remains the same. Since the base and height are unchanged, the new triangle has the same area as the original triangle. In fact, any triangle formed by moving the top point along this parallel line will have exactly the same area as the original triangle. But this formula doesn't stop here. It also applies to triangles with obtuse angles, where the height is outside the triangle. So how can this concept help us solve the problem? We have a square with a point inside, connected to the midpoints of the sides, dividing it into 4 regions. The areas of 3 regions are given as 16, 20, and 32 square units, and we need to find the area of the green region. So how can we solve it? Let's get started. To solve this, let's first create triangles by connecting the interior point to the 4 corners of the square. This divides the square into 8 smaller triangles. Now, let's color code the regions. The region with an area of 16 is orange. The region with an area of 20 is blue. The region with an area of 32 is yellow. The green region is the one we need to solve. Let's focus on the triangles along the bottom side of the square. These 2 triangles are divided at the midpoint of the base, so their bases are of equal length. Additionally, both triangles share the same height. Since they have equal bases and heights, their areas are equal. Let's denote this area as A. We'll repeat this process for the other 3 sides of the square. Next, let's move to the left side of the square. Again, the triangles have equal bases and heights, so their areas are equal. Let's call this area B. For the top side, the 2 triangles also have equal areas, which we'll call C. Finally, for the right side, the 2 triangles have equal areas, which we'll call D. Now, let's use the given areas of the color-coded regions to set up equations. Orange region, A plus B equals 16, this is the equation 1. Blue region, B plus C equals 20, this is the equation 2. Yellow region, C plus D equals 32, this is the equation 3. The green region, which we need to find, is where A plus D. Let's add the equations for the orange and yellow regions. We get A plus B plus C plus D equals 48. Substitute B plus C equals 20 into the total, B and C, get cut off, and we get A plus D equal 28. So the answer of missing area is 28 square cm. This solution works because of the symmetry of the square and the equal division of triangle areas. Now it's your turn. Here's a similar puzzle with new values. Can you solve it? Drop your answer in the comments, and I'll pin the first correct response. If you enjoyed solving this viral puzzle, don't forget to like, subscribe, and hit the notification bell for more fun maths challenges. Thanks for watching, and I'll see you in the next video.